Hello everybody, in this video I'm here to explain how to do an astronomy problem. Its name is Mongoliearth. In this problem, Mongoliearth is an outer planet which is identical to Earth in terms of density and albedo. Its surface is 1.564 million kilometers squared and is seen every 1.235 years. In this problem, we are tasked with finding its gravity on its surface in terms of g, or gravity of the Earth, and the phase where H2O will be in on that planet's surface, given that it has a circular orbit and its temperature is homogeneous throughout its surface. So let's get to it. We know that Mongoliearth is a planet, and we know that all planets are spherical. Therefore, we can apply the surface area of a sphere onto the surface area of Mongoliearth, and we know its surface area. So we know that A is equal to 4 pi r squared, and that way we find that r is equal to the square root of A over 4 pi. And now that we have its radius and its density, we can find its mass, which will be used for finding its gravity based on Newton's law of universal gravitation, which states that the acceleration of gravity from the object is equal to gm over r squared. Theoretically, we can find the m, or the mass of Mongoliearth, but I'd rather just expand it, which means that m is equal to 4 over 3 pi rho r cubic, and the r cubic on the top is easily divisible by the r squared in the bottom, giving us that the g is equal to 4 over 3 times the gravitational constant times the rho times the r. Now we substitute the radius from equation 1 to equation 2, which gives us that the gravity of the surface of Mongoliearth is equal to 4 over 3 times gravitational constant times its density times its radius, which is the square root of A over 4 squared. Now we must divide it by the gravity of the Earth to find it in terms of g. And note that 4 over 3 times the gravitational constant times the density of Mongoliearth is equal to 4 over 3 times the gravitational constant times the density of Earth. So theoretically, it's basically just the radius of Mongoliearth divided by the radius of the Earth. Or we can just substitute the radius of Mongoliearth from equation 1, which makes it 1 over the radius of Earth multiplied by the square root of the area of Mongoliearth divided by 4 pi. And if you do the computations, you will find that the gravity on Mongolia's surface is equal to 0.055 g. Alright, moving on to part B, we know that Mongoliearth is an outer planet, which means that its period of revolution around the Sun should be longer than Earth's. So we can apply the formula of synodial period, which is stated in the problem, 1.253 years. Alright, if we were to do the algebra here, and we will find that the period of Mongoliearth's revolution around the Sun is equal to the synodial period multiplied by the period of the Earth divided by the synodial period subtracted by the period of the Earth. Now, what does this period have to do with its temperature? Well, it's still part 1. Part 2 of this is we must apply the third law of Kepler's movements, which states that for two objects orbiting the same thing, such as Mongoliearth and the Earth both orbiting the Sun, the semi-major axis cubic divided by the period squared should be constant. And if we did that for Mongoliearth and the Earth, we will find that the semi-major axis of Mongoliearth divided by the semi-major axis of the Earth is equal to the cubic root of period of Mongoliearth divided by the period of Earth squared. Alright, that still doesn't tell us anything about the state of water. Then we must look at the flux that both planets take from the Sun. So we know that a flux is proportional to 1 over the distance, or in this case, the semi-major axis squared. And we will get, and if we were to do the algebra here, we will find that the temperature of a planet is equal to the temperature of the Sun times the fourth root of the radius of the Sun squared divided by 1 minus the albedo times 4 times the distance to the Sun squared. We know that the Earth and Mongoliearth rotate around the same object, the Sun, and it also has the same albedo. Alright. But first, we have to compute the temperature of the Earth, given that it has a circular orbit and its temperature is homogeneous throughout its surface, which we will get to be 305.828 Kelvin. Now, if we were to divide that by the temperature of Mongoliearth, it will just be equal to the square root of the distance from the Earth to the Sun divided by the distance from Mongoliearth to the Sun, which will get 178.933 Kelvin. Now, in this case, H2O will be ice, or it will be solid. Okay, that's all for this video. Hope you enjoyed and learned something new. Thank you.